Alright, so let's tackle number 16 from the review, the flu problem. So I kind of color-coded to show where things are coming from, and I have two different ways to look at it. One from a standpoint of a tree diagram. So if we're looking here, the probability to randomly select a student has a flu is 35%. So we're kind of starting here, and either you have the flu or you don't, and there's a 35% chance you have the flu. That's the pink. Then the probability that a student who has the flu also has a high fever is 90%. So that's going up here to has or high fever. Then the probability that a student who doesn't have the flu, so that's down on the bottom, down at this one, and of course if there's 35% chance of getting the flu, there's a 65% of not getting the flu. So given from there, having a high fever is 0.12. Now the opposite, having or not having the flu and not having a high fever is 0.88 because they have to add up to 1. So the ones that we care about is the high fever. We want the probability of the flu given that we have a high fever. So using our conditional probability formula, it's the probability of flu and high fever over the probability of high fever. Well, flu and high fever is that number there, 0.35 chances we get the flu times the probability that we get the flu, or sorry, if we have a high fever, that we have the flu, we get the high fever. And then, so that's our flu and high fever. Now high fever has got to be both of these, because either they have the flu and a high fever, or we don't have the flu and a high fever, so we got to add those two together. We get 0.393. So 0.315 divided by 0.393 is 80.2%. And that's how we can use a Venn or a tree diagram to figure out our probabilities. Now the other way that we can figure out our probabilities, algebraically. So first, the idea that I'm using, or the whole concept, is that we can use our conditional probability formula, probability of A given B, equals the probability of A and B divided by the probability of B, the second thing. We can rearrange that by multiplying by the probability of B on both sides, so that we get the probability of B times the probability of A given B is the same as the probability of A times B. And that's what we're going to use. So, I have it written a couple different ways. So we want the probability that they have the flu given they have a high fever. So again, this is what we want. That's our formula. But also kind of rearranging the formula, the and of that is the probability that we have a high fever given the flu times the probability of having the flu. And that's over the probability of having a fever. Now, the probability of having a fever is either the flu and high fever or not the flu and high fever, which, because they're not independent, we can switch around as well, just like we did here in the blue with this formula. The probability of flu and high fever is the probability of high fever given that we have the flu times the probability that we have the flu. And likewise with the flu complement on the other side. So the probability, now we're just going to use things that were given to us from the problem that we're looking at. So the probability that we have a high fever given the flu is 0.35. They told us that. Or that's just the probability of flu, sorry. The probability of a high fever given the flu is this 0.90. Now that's going to also be in our denominator, because that's one of the ways we can have a high fever when you have the flu, but we can also have the flu or have a high fever when we don't have the flu. So there's a 0.65 chance of not having the flu, and there's a 0.12 chance of if you don't have the flu, having a high fever. So it's just a substitution. And again, we get the same thing, 0.35 times 0.90 over 0.35 times 0.90 plus 0.65 times 0.12. Either way, we get the same thing, and it all comes down to this right here. You got to be able to rearrange the formulas. Because an and probability is always multiplication. Sometimes it's not independent, and that's what we had to use here. So hopefully this is a little bit clearer and not too muddy.